Okay, so picking up with the Ctenophora, the C is silent. These are our comb jellies. And one unique feature about our ctenophores is these two long retractable tentacles that they use to capture their prey. And along their tentacles, they have these cells called colloblasts, which is very similar to our nematocysts in our cnidarians, but they do send a discharge of a strong adhesive material to grab onto their prey and haul it in. They are a step up in complexity to our cnidarians. They are more complex. Here we actually have an anal pore. All right, so with our cnidarians, they didn't have that. That mouth was also the anus. They bring their prey in and then break it down in the gastrovascular cavity, and then discharge whatever did not get consumed. And now with our cnidarians, we actually have an anal pore. So these guys are exclusively marine. You don't find them in freshwater ecosystems. No nematocysts. Instead of stinging cells, we have these sticky cells called the colloblasts. Okay, anything else I want to talk about? No, I think I hit it all. These guys, I guess I should mention, they do have muscles. Okay, so if they have muscles, are they diploblastic or tripoblastic? Triple, right? If you have muscles, then you have all three of the germ layers, so you are considered triploblastic. All right, so here's some diagrams of the comb jelly, and you can see these two long tentacles that come out, and it's retractable, so they can bring it on in. And then just a zoom of that colloblast cell, that sticky adhesive, these adhesive granules that grasp onto their prey. Do they show the anal pore in any of these diagrams? Oh, there it is. Oop, there it is. So anal pores. Okay, all right. Gesundheit. Okay. Review questions. True or false, nematocysts are the most complex structures secreted by single animal cells. Yes, true. The larval stage of a cnidarian is known as a B, linule A. Which of the following classes has an endosymbiotic relationship with a dinoflagellates? Think coral reefs. It's A, Anthozoa, right? Anthozoa, think flowers, okay, flowery things. So it is A, Anthozoa. Okay, so now we're going to transition to Bilateria from pretty much here on out, unless otherwise stated. And it's a short little section here, but we're going to cover the Acela, which means they do not have a body cavity. So I believe I just have one slide on them. So Bilateria clade is characterized by obviously bilateral symmetry, and it's made up of two clades, the acele flatworms, which is depicted here, and then a clade comprising of your protostomes and deuterostomes, which we'll cover in chapters 34 and 35. And so these flatworms lack a body cavity. Their nervous system is very rudimentary, just a simple network of nerves, which some heavy concentration of neurons that kind of serves as the head of the body, so anterior, think head. Does lack a permanent digestive cavity, and we traditionally classified them with our platyhelminths, which are flatworms, but because of technology, now we can analyze them molecularly, and we have realized that they are not closely related. They are now a sister taxon to the flatworms, which we will jump into in chapter 34. All right, so the review question, acele flatworms, D, sister taxon to the clade comprised of protostomes and deuterostomes. Okay.